So a huge problem with switching gears and stuff is the gears have to line up right. If you have two gears hitting each other and the gears are not perfectly lined up, you can imagine that they don't fit into the pointy part doesn't fit in the hole of the other part. Two points hit each other, or they are not lined up perfectly well. Otherwise, it can cause a bunch of shock, stress. It can even break the gears. It can cause other mechanisms to bend and break over time. Now, there's a variety of ways around this to let for smooth rides and safer rides and more efficient rides. Now, these variety of methods are all good and so, but I'm going to propose a simpler way that I think modern day technology will allow for and has less chance of failing. Now, alternative ideas to make gears switch back in and out is electric motors and other motors having sensors so they can time everything precisely. And then if they can time it precisely, you can fit it in the exact right time. There's also gears with that spin much slower they can use to engage in the right time. Because they're the ones that fit in more slowly, you have more time to adjust everything in the right way. You can have multiple steps to fit stuff in together. You can have other methods of doing this that may include just using belts and stuff to get rid of some gears, but belts will have some problems too. You can use you can just take the sock, which is usually a very bad idea. And there's ways that we can avoid gears altogether, like electric motors can ramp up the power versus speed and horsepower and change and just all the horsepower versus speed and all that without actually having any gears. There is a reason why we still have gears in electric motors, and that's because electric motors work most efficiently at a certain speed and torque and everything. But we can eliminate a lot of gears, which also makes the whole car more efficient, because with the more gears you eliminate, the less weight and less points of failure, but you always hit the point of failure with electronics then. But it's less stuff overall to worry about. So here is my proposal for, also you could include a bunch of small electric motors instead of one big one, but then you have ways of extra electric motors and stuff instead of using gears. So here's my proposal for alternative gear setup using more modern day technology. And I know the gears are not star safe, but let's pretend they are. Is that you can have a gear that the tips are more flexible than, or parts of it are more flexible and can compress and decompress compared to a more rigid interior. And this would allow it when you're putting in, if it's not perfect, for it to deflect and slowly catch up. So first if it hits it slightly wrong, let's say this hits one of the tips can bend and push this a little faster, more forward into place and turn it. So tip bends and it pushes it more forward until it engages in the right part where there's the least bending amount of energy possible. And then by changing, to make it really strong and durable, by changing the amount of flexibility and give, we can make it not lose that much energy to elastic changes in the material and make it durable. But that will require more advanced manufacturing techniques such as 3D printing or laying it one by one radially. Another thing is to build stronger materials that are still flexible. And with carbon nanotubes and other common composites, that's becoming more and more of a possibility. Also to get rid of some of the wear and tear or bumps and stuff lost, we can use a timing electric motor in this series to speed up the modes and time it better. But this is an add-on to that. So we have two ways. So the electric motor way of timing and everything fails, we have this to work with. Another thing that could be done is to encase this whole thing in a fluid, which could help speed up more before it even contacts it to the right amount and line up stuff with fluid friction, and also prevent some wear and tear and heat dissipation, help with heat dissipation. Another problem that this whole thing will experience is, and with any flexible system, is vibrations, both sapping away some of the energy and causing more wear and tear and less of a smooth ride. To get rid of vibrations in the system, you could vary the material density throughout the material and the material composition. So sound waves do not travel as easy through the material because they're hitting materials that have different densities, which causes them to bend in all sorts of ways. Now, the bending does a bunch of different things. Sometimes that bending is going to cause one sound wave to bend and hit another sound wave that's out of phase. So if you imagine one sound wave takes a path that's slightly longer and comes in out of phase, perfectly out of phase of this sound wave is on, the peak and the bottom cancel out another one, cancel out the sound waves, dissipating all the energy and reclaiming it for moving without damaging the vehicle. Another thing is that by making it constantly bend and forth, sound waves dissipate some of the energy because it has to travel through more of the material itself. Also, you can redirect the sound waves over more of the whole vehicle, so it's less of a focus bump and less chance that any place has a focused amount of energy that causes breakage or decay. Another thing is, by including more soft material in these different places, you have more material naturally to absorb sound waves. Also, different materials transmit sound waves in different manners. Some of them transmit it through whole movements of big lattices. Some of them more individual little molecules move. Some of it is more like a spring-like mechanism around the same molecule, and so on and so on. So just to illustrate this 3 ones quickly, you can have a spring, you can have like a whole big block move back and forth, or you have blocks that hit other blocks that are much smaller. And there's also a variety of other ways, with different types of molecules move in different ways is the basic point. Also, some molecules spin more than other molecules because they have like, they're not as round or have asymmetric state, and different molecules transmit sound waves in different directions better. So you have all that, and when it hits a material that transmits sounds in different ways, some of the energy is again dissipated or redirected, furthering these impacts. Something that transmits a big giant block is not as good as transmitting to a fluid. Or something that spins around more. Another thing is that at different is you can further away stuff's transmit if you have different things that are different bonded to each other. So if you have a metal doesn't bond as well to a plastic, so metal is more likely to slide back and forth without transmitting its energy to a plastic. Another way you can get rid of some energy that way. Another advantage of using carbon nanotube composite, I forgot to mention, is that it's better at getting rid of heat in itself, which will really help make this more of a doable thing and work better. And so one other, I think, for this suggestion about how to make this doable, and this was this little thing I drew here, is traditionally it's hard, but with new 3D printing manufacturing techniques and other ones, when printing this out of actually more composites with plastic and stuff, is instead of using gears where the gear mesh is like a flat thing, so you see like a peak like this and it just goes to another peak like that. I'm saying the surface that it's engaging is flat. You have gears where it's like a V shape where it's engaging that goes up and down. So if my ugly 3D drawing would look like this, really ugly 3D drawing, but it has a V shape to the teeth, and that the advantage of a V shape to a teeth is a couple folds with reducing shock waves and vibrations and decreasing energy loss, is that there's more surface area for this whole thing to contact it, so stress on this whole gear and is just to be along the whole V-shape. And that whole V-shape giving around stress means that at any particular point has less stress. Also, V-shape with triangle tends to be stronger shape, and it has and if it's a little bit off, the V-shape puts the whole thing back into right center. Now, an even better one, in my opinion, would be a circle instead of a V. The advantage of a circle is it can handle stress even better because stress, it's a stronger shape overall, like a self-supporting arch bridge. But also, sound waves and shock waves, when they travel around it, circles are some of the worst shapes to travel around. And you can see this with that the circle constantly bends direction. And by having it constantly bend direction, sound waves like this travel in straight lines. But now the sound wave has to bend and bend and bend. And that can dissipate a lot of the energy of a sound wave and make it travel even farther distance in a safe mode. All this, I think, is really doable now with 3D printed composites with carbon nanotubes or other smart designs. Well, thank you very much for listening. Please like and subscribe. It really helps to turn out. I'm trying to reach 1,000 subscribers in a year and 4,000 watch hours, which is really hard, but with your help, I think I can do it. Also, if you have any ideas for future videos, comments, or suggestions, please leave them in the comment section below. Again, thank you very much. Goodbye.